If you were to place Betelgeuse where the Sun resides, it would stretch to the orbit of Jupiter, becoming a massive, unstable force on the brink of exploding. This phenomenon exemplifies some of the most striking manifestations of radiative energy across the cosmos, emitting more power than billions of suns. Betelgeuse, often compared to a terrifying insect, is a red supergiant star. Should you position it where our Sun is, it would extend to the orbit of Jupiter, an unpredictable entity destined to eventually detonate. When thinking about stars, we often imagine the tiny twinkling lights in the night sky. This is simply how we observe them from Earth, but stars themselves are far more intricate. One of the most prominent stars, Betelgeuse, is far grander than our Sun. For years, this star has puzzled scientists, but recently, something even more concerning has unfolded with Betelgeuse, which has caused great worry among researchers and other specialists. Join us as we delve into the fascinating new revelations about Betelgeuse, its impending explosion, and how these developments will impact both our universe and life on Earth. As renowned physicist Michio Kaku explains, Betelgeuse is a remarkable phenomenon, an enormous star that has captivated astronomers for centuries. A Greek astronomer named Antonius was the first to discover it. This star is so immense that it can be seen in the night sky from Earth, particularly during the winter months. If you're passionate about astronomy, you've likely heard of or observed this star. The reddish-orange star marks the upper left shoulder of the Orion constellation. So, while Betelgeuse is old, it's also one of the most awe-inspiring stars visible in the sky. Yet, one fascinating aspect of its brilliance is that it doesn't remain constant, it fluctuates. This variability is a defining feature of the star, but it's far from the only interesting characteristic to explore. When examining Betelgeuse's attributes, we note that most of the stars visible in the night sky are incredibly distant. The closest star to Earth is 4.2 light-years away. To understand light-years as a measure of distance, imagine traveling at the speed of light for an entire year. It's been shown that light can travel 186,000 miles per second. So, over the span of 1 year, light would cover billions of miles, which means that when we say the closest star is 4.2 light-years away, we're talking about a vast distance. That's billions of miles, far from our planet. However, Betelgeuse is much farther than that, roughly 600 light-years away from Earth. This means that even traveling at the speed of light, it would still take 600 years to reach it. While our fastest space rockets can't approach those speeds, Betelgeuse's light is still so powerful that it shines brightly from such a distance. You might wonder how Betelgeuse is able to shine so brightly despite its vast distance from Earth. This is due to its extraordinary size and luminosity. Betelgeuse is about 10 times larger in mass than our Sun, and its radius is several times bigger. Unfortunately, due to the limitations of current telescopes, Betelgeuse appears as a blurry disk in space rather than a tiny point of light, which is what most stars look like. This effect is due to the outer layers of its atmosphere. Regarding its mass, Betelgeuse is thought to be between 12 and 19 times heavier than the Sun. A solar mass refers to the standard unit of measurement in astronomy, equivalent to 2 times 10 to the power of 30 kilograms. Because there are no companion stars orbiting Betelgeuse to compare its mass to, scientists can't pinpoint its exact weight. However, even at the lower end of the mass estimate, Betelgeuse is still many times heavier than our Sun. The brilliance of Betelgeuse fluctuates between magnitude 0 and 1.6. To put that into perspective, a star with a magnitude of 0 is 2.5 times brighter than one with a magnitude of 1. At its brightest, Betelgeuse can outshine our Sun multiple times. This change in luminosity is due to its pulsations or cyclical expansions and contractions. As Betelgeuse expands, it becomes brighter, and when it contracts, it dims. These pulsations can last anywhere from 10 days to 100 days or even longer. A unique feature of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is much stronger than that at the star's regular surface. These magnetic spots interfere with the movement of hot gases toward the star's outer layers, causing these areas to cool down. The fact that Betelgeuse has more of these spots than our Sun is why it appears cooler, even though it's much larger and brighter. The Sun also has dark magnetic spots, but those on Betelgeuse are far larger and more numerous. For context, some of the spots on Betelgeuse are twice the size of Earth. Additionally, Betelgeuse has a magnetic field that is many times more powerful than that of the Sun. This field causes the gases on its surface to appear as if they are swirling or bending when observed through a telescope. Betelgeuse has a surface temperature of around 3,500 K, which is quite low for such a massive star. This low temperature contributes to its faint red color, which is typical of red supergiant stars. Interestingly, Betelgeuse wasn't always red. Around 100,000 years ago, it was yellowish, much like our Sun. Over time, its color has shifted from yellow to orange, then red, and about 10,000 years ago, it began to settle into the red hue we observe today. This gradual color change has led researchers to believe that Betelgeuse is still evolving. Betelgeuse emits roughly 10,000 times more energy than our Sun, which would make it a formidable rival to our Sun if it were closer. The fact that Betelgeuse, located 600 light-years away, is still visible to the naked eye at night is remarkable. Our Sun is only 8.3 light-minutes away from Earth, which is why it appears so much brighter and more powerful. Were Betelgeuse closer, we would be able to see it during the day as well. However, if it replaced the Sun, it would swallow Earth and the other nearby planets due to its immense size. In addition to its size, Betelgeuse releases much more radiation than our Sun. Known as a red supergiant star, Betelgeuse is situated in the constellation Orion, around 600 light-years from Earth. Its colossal size is one of its most notable features, as it is many times larger than our Sun's radius and could easily encompass the orbit of Jupiter if it were placed at the center of our solar system. This vast size causes Betelgeuse to appear as a disk instead of a small point of light when observed through powerful telescopes. Despite its size, Betelgeuse is not the largest star we know of, as its mass is between 12 and 19 times that of the Sun. The variation in Betelgeuse's mass estimates arises from the difficulties in accurately measuring the mass of stars that don't have companion stars or other objects orbiting them. Even with its lower mass estimate, Betelgeuse remains an enormous celestial body. Another important characteristic of Betelgeuse is its varying brightness, which fluctuates continuously over time, from magnitude 0 to 1.6. At its brightest, Betelgeuse can be multiple times more luminous than the Sun. This variation in brightness is due to the star's pulsations, internal processes causing it to expand and contract. When Betelgeuse expands, it grows brighter. When it contracts, it dims. These pulsations can last for weeks or even months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, around 3,500 K. This contributes to its red color, which is typical of red giants nearing the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution, having exhausted its hydrogen fuel and now fusing heavier elements in its core. This fusion process generates energy, causing the star to expand outward. The star's surface is also marked by dark magnetic spots, where the magnetic field is stronger than in other regions. These spots prevent heat from moving upward, leading to cooler areas on the surface. Despite these cooler regions, Betelgeuse remains a massive and brilliant star, but it will eventually meet its end in a dramatic explosion. Betelgeuse, like all massive stars, will eventually run out of fuel. When this happens, it will undergo a rapid fusion process, creating even heavier elements like helium and carbon. This will cause the star to expand to possibly even greater sizes, making it one of the brightest objects in the sky before it dies in a supernova. A supernova is an extremely powerful explosion that marks the death of a massive star. The force of a supernova is so strong that it can briefly outshine an entire galaxy. The shock waves from such an explosion could even trigger the formation of new stars in nearby regions, continuing the cycle of stellar birth and death. Betelgeuse's potential supernova is something that scientists are closely monitoring, as it may occur in the near future, although it's impossible to pinpoint when exactly it will happen. In recent years, astronomers have noticed unusual changes in Betelgeuse's brightness, fueling speculation that it might be nearing a supernova. However, predicting the exact time of the explosion is difficult. Some scientists estimate that Betelgeuse could go supernova within the next 100,000 years. While this might seem far off in the grand scheme of the universe, it's still too distant to be sure. The James Webb Space Telescope, JWST, has offered new insights into the star's behavior, allowing scientists to study its outer layers and magnetic fields in unprecedented detail. JWST's findings confirm the star's irregular brightness and potential instability, providing valuable information about the processes that lead to a star's death. Betelgeuse's eventual supernova will have wide-reaching effects on the universe. The shock wave from the explosion could trigger the formation of new stars in nearby regions, continuing the cycle of stellar birth. Moreover, the heavy elements produced by the explosion, such as iron and nickel, will spread throughout space, enriching the interstellar medium and contributing to the formation of new stars and planets. This process is essential for the creation of future generations of celestial bodies. While we won't be around to witness Betelgeuse's final moments, its study offers invaluable insights into the life cycles of stars and the broader workings of the universe. By understanding how stars like Betelgeuse evolve and eventually meet their end, scientists can learn more about the forces shaping our universe. Betelgeuse's legacy will live on, not only in the elements it creates but also in the knowledge it has provided to generations of astronomers. Studying stars like Betelgeuse helps us unlock the mysteries of space and our place within it, reminding us of the vastness and complexity of the cosmos. Betelgeuse's eventual demise represents more than just the death of one colossal star. It's a pivotal moment in the grand cycle of stellar evolution. The supernova explosion will not only mark the end of Betelgeuse's life but will also enrich the cosmos with new elements, contributing to the creation of new stars, planets, and even life as we know it. This process is essential to the continuous renewal of the universe. The remnants of the explosion, neutron stars, black holes, and enriched gas clouds, will all play significant roles in shaping the next generation of cosmic structures. As we continue to explore the vast mysteries of space, Betelgeuse serves as a reminder of the ever-changing nature of the universe. It's a powerful example of how stars live, evolve, and eventually die, and how their deaths give birth to the building blocks for the next phase of cosmic development. Although Betelgeuse's ultimate fate may seem distant, it will leave a profound impact on our understanding of the universe and the fundamental processes that drive the birth and death of stars. This research, and the knowledge it provides, will continue to shape the future of astronomy for generations to come. The study of Betelgeuse has also provided scientists with new tools and technologies, allowing them to peer deeper into space than ever before. With instruments like the James Webb Space Telescope, researchers are gaining unprecedented views of distant stars and their behavior. These observations are shedding light on the life cycles of other massive stars, offering us a clearer picture of how the universe operates on a larger scale. The discoveries made through these studies not only improve our understanding of individual stars, but also help us grasp the broader patterns and dynamics of the cosmos. By observing Betelgeuse and other similar stars, astronomers hope to unravel more of the mysteries of stellar formation, evolution, and death. These insights will deepen our knowledge of the forces that shape the universe and how celestial objects influence one another. As we continue to study Betelgeuse's behavior and eventual supernova, we're learning more about the complex and interconnected nature of space. Despite the challenges of predicting exactly when Betelgeuse will go supernova, its study is already contributing to a more comprehensive understanding of stellar life cycles. The information gleaned from this research will be crucial in answering many fundamental questions about how stars live and die. For example, what causes certain stars to evolve into red giants like Betelgeuse? How do the physical characteristics of stars influence their eventual fate? What will the universe look like after the explosion of a supernova, and how will it continue to evolve? Through the lens of Betelgeuse, we are beginning to glimpse the intricate processes that govern the universe. Its eventual explosion will not only offer us a dramatic, cosmic event to observe, but will also provide valuable data that will help scientists predict the behaviors of other stars and refine their models of stellar evolution. By continuing to observe and study Betelgeuse, we're enhancing our understanding of the universe's past, present, and future. Ultimately, Betelgeuse's fate is part of a much larger story, one that spans billions of years and unfolds on a cosmic scale. The end of Betelgeuse, while inevitable, represents a crucial part of this ongoing narrative. Stars like Betelgeuse play an essential role in the creation and destruction of elements that make up the universe. These elements, produced in the cores of stars and released during supernovae, are the building blocks of new stars, planets, and even life itself. Without the death of stars like Betelgeuse, the universe as we know it wouldn't exist. The death of Betelgeuse will be a magnificent and awe-inspiring event, but it will also signal the beginning of a new phase in the cosmic cycle. The supernova's shockwave will catalyze the formation of new stars, and the elements it releases will seed new solar systems, creating the conditions for new planets to form. This cycle of birth and death is fundamental to the universe's evolution and is a reminder of the constant change and renewal that defines space. In the broader context of astronomy, the study of stars like Betelgeuse is not just about observing distant objects in the sky. It's about understanding the fundamental processes that govern the universe, from the birth of stars to their eventual demise. By studying these celestial giants, scientists are able to gather insights into the history and future of our own solar system, as well as the larger cosmic environment. As we learn more about the life cycles of stars, we gain a deeper appreciation for the intricate, interconnected nature of the universe. Although we may not be alive to witness Betelgeuse's final moments, the research conducted on this star will continue to impact future generations of astronomers. By observing the forces at play in Betelgeuse's life, we are advancing our knowledge of the universe and contributing to the ongoing exploration of the cosmos. This knowledge will allow future generations to better understand their place in the universe and the forces that govern the stars and planets around them. As we reflect on the life and eventual death of Betelgeuse, we are reminded of the vastness of space and the incredible complexity of the universe. Stars like Betelgeuse may be distant, but their impact on our understanding of the cosmos is profound. By continuing to study these celestial giants, we can unlock the mysteries of the universe and gain a better understanding of the forces that shape our existence. The legacy of Betelgeuse, and the lessons we learn from it, will continue to shape the future of astronomy and the way we perceive the universe.